Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniel here, and today I'm gonna continue to talk about binomial option pricing models. In this lesson, I'm gonna focus on the multi-period models and other underlying assets. The targets of this lesson is to extend the binomial model to multi-period setting for pricing both European and American call and put option, and extend the binomial model to other underlying assets, including stock indices with continuous dividends, currency, and future contracts. First, let's consider two-period binomial tree. Remember in the last video we talked about the one-period binomial tree with no dividend. Today we are going to talk about the two-period binomial trees with no dividends. So let's say S0 is the initial stock price. The length of each time step is H years. The stock price either moves up to U times its current value or moves down to D times its current value. The risk-free interest rate is R. So here, since we have two stages, so we got a tree look like this. At the initial time, the stock price is S0 and the payoff option is C0. Then after each years, remember the length of each time step is H years. So after one step, after H years, the stock price can either moves up or moves down. So if the stock price moves up, then the new stock price should be S0 times U, and the payoff should be CU. Otherwise, it should be S0 times D, and the payoff is CD. Now, from step 1 to step 2, we have S0 times U squared if it's continue to move up, and the payoff is CUU. If it's moved down from step 1 to step 2, then the new stock price should be S0 times UD, and the payoff is CUD. And similar for the second branch. So by doing so, we have three possible possibility at the time 2. And here, in order to calculate the payoff, we first have to calculate the probability of going up, because at the time 1 we have two possibilities, so we need to find the probability of each event. Here P star is calculated by e to the r minus delta times h minus d over u minus d. Then the payoff at time 1, in case that the stock price move up, is CU, which is calculated by e to the minus RH time with B star CUU plus 1 minus B star some CUD. Then CD is the stock price in case is moved down. So CD is e to the minus RH time with B star CUD plus 1 minus B star some times CDD. And the initial stock price C0 is e to the minus RH time with B star some CU plus 1 minus B star CD. So basically, we have to calculate backwards. We have to start at the end notes and then calculate to the earlier notes. See that? Let's reconsider the risk-neutral pricing model based on a two-period binomial tree. Remember that the initial payoff should be e to the minus 2 RH time with B star squared times CUU plus 2B star times 1 minus B star times CUD plus 1 minus B star squared times CDD. So in this case, if we consider a new random variable Ct with the probability distribution described as the following, that probability of Ct is equal to either b star squared if Ct is equal to Cuu, or 2 times b star times 1 minus b star if Ct is equal to Cud, or 1 minus b star whole square if Ct is equal to Cdd, then the initial price C naught is equal to e to the minus 2rh times expected value of Ct. Now multi-period binomial trees. For a tree with n steps, there are n plus 1 n nodes. The k nodes k is equal to 0 to n has value s naught times u to the k d to the n minus k's. The original true probability that the kn nodes will be reached is n choose k b star to the k times 1 minus b star to the n minus k. So this is how we calculate the payoff in case we have multiple period. Let's consider this example. Example 1. You are to price a 2 years 104 dry European put option on a non-dividend paying stock with a binomial model. You are given that the current price of the stocks is 100. The binomial tree consists of 2 time steps of 1 year. In each time step, the stock price either moves up by a proportional amount of 30% or moves down by a proportional amount of 30%. The continuous compounded risk-free interest rate is 5%. Calculate B star and the current price of the put option. So first we have to find the probability, right? B star. B star is equal to e to the 0.05 minus 0.7 the whole thing over 1.3 minus 0.7, which is 0.59. Just follow the formula. Now remember, for binomial tree we need to calculate the n node and then calculate the beginning node, right? So here first we have the n node in case it moves up 2 times is Cuu. That is the payoff. Remember, this is a put option, so the payoff is a positive function of k minus s0 times u squared. S0 times u squared here is a stock price at time 2 in case that the stock price keep raising up twice. So it should be 104, subtract 100 times 1.3 squared, take the positive function and you got 0. Then CUD is equal to 104 subtract 100 times 1.3 times 0.7. Take the positive value between that and 0. So we got, it should be 13 for CUD. And the payoff for CDD is 55. Now we got CUU, CUD, CDD. We can use the formula of the initial payoff to calculate the current price of the option, of the put option. So we got C naught is equal to e to the minus 2 times r times h times 0.59 squared, this is b star squared, times with CUU, which is 0, then plus 2 times with b star times CUD, plus b star times CDD, and we got 31.2. Alright, now we consider how to price American option. For American option, we also can use multi-period binomial tree, but the calculation is somehow different at the middle nodes. Of course, it should be the same for the end nodes. So In order to understand American option better, let's consider this example. For 2 pairs binomial model for stock prices, you are given is period is 6 months, which is half year. The current price for a non-dividend paying stock is 70. Let's U is 1.181 and D is 0.89. The continuously compounded risk-free interest rate is 5%. Calculate the current price of a 1-year American put option on the stock with a strike price of $80. So remember, for no matter we're working on European option or American option, we have to first calculate the end notes. Here the end notes are the same for both American option and European option. B star, the probability of moving up is e to the 0.05 times 0.5 subtract 0.89 over 1.181 subtract 0.89, which is 0.465. Then we use the payoff formula to find the payoff at time 2, CUU, CUD, and CDD. Remember, this is a put option, so the payoff should be the positive value between the try subtract the price and 0. For CUU, the price should be 7 times U squared, and the try is 80. So we got 80 subtract 70 times U squared, and take the positive value between it and 0. We got 0 is CUU. Similar, we got CUD is 80 subtract 70 times UD plus. So it should be 6.4237, and CDD is the same, 80 subtract 70 D squared plus, which is 24.553. Now we have the end notes. For the middle notes, for American option, we cannot jump from the end note to the initial time. We have to calculate the middle note. Here CU is calculated a little bit differently compared to that in European option. Here CU is maximum between 80 subtract S naught and time use and e to the minus 0.05 times 0.5 times 0.465 times CUU plus 0.535 times CUD, which is the maximum between -2.67 and 3.35, which is 3.35. CD is the maximum between 80 subtract S naught D and e to the minus 0.05 times 0.5 times 0.465 times CUD plus 0.535 times CDD, which is the maximum between 10 and 17.7, and we got 17.7. C naught is the maximum between 80 subtract 70 times e to the minus 0.05 times 0.5 times 0.465 times 3.35 plus 0.535 times 17.7, which is 10.75. Probably you not really understand how these are calculated, so I'm going to walk you through a couple of formulas. Alright, so for American option, first we also have to calculate the probability of moving up, which B star is equal to e to the minus RH minus D over U minus D. Then for the end note, we basically calculate it exactly the same with European option. CUU is the strike price between K subtract S naught U squared plus CUD is strike price subtract S naught UD plus, and CDD is the strike price subtract S naught D squared plus. Then we have to calculate CU. CU is the maximum between K minus S naught U, B star times CUU plus 1 minus B star times CUD. CD is equal to maximum between K minus S naught D, B star times CUD plus 1 minus B star times CUDD. C naught is equal to maximum between K minus S naught and B star times CU plus 1 minus B star times CD. So for American option, you cannot jump from the end note to the initial note. We have to calculate the middle notes. If we look at the graph, basically we have to calculate the end notes right here, CUU, CUD, and CDD, by using the formula of payoff for put option. Then we have to calculate backwards in order to find CU and CD. And once we got CU and CD, we calculate backward to find CU is 0. And here CU is calculated by CUU and CUD. CD is calculated by CUD and CDD. See that? Alright, now we are going to consider the case when volatility is known. So we consider how to construct a binomial tree when the volatility is known. When the volatility is known, that means sigma is given. We can use the forward tree method to compute U and D as follows. U is exponential of R minus delta H plus sigma square root of H. And D is exponential R minus delta times H minus sigma square root of H. B star is equal to 1 over 1 plus e to the delta sigma square root of H. Estimated stock volatility. Historical volatility is, as its name suggests, an estimate of volatility from historical stock prices, n plus 1 number of observation. Let UI is natural log of SI over SI minus 1. So SU square is the variance, the sample variance. So we have to use the sample variance formula in order to find SU squared. That's the basic thing in statistics. So SU squared is 1 over n summation UIs minus U bar whole square. And the estimate of volatility is sigma hat, which is equal to SU over square root of H. Alright. So that's it for today. Thanks so much for watching and hope you guys enjoyed my lesson. See you on the next video. Bye bye.